Speech 3, research-based star formation. I have my mom and Tim. You look up in the sky about noon. First thing you see before it blinds you is the sun. What is the sun? Well, I think most everybody knows the sun is a star. But no one really thinks to ask, what exactly are stars? They seem to be not very interesting to most. However, once you get to know them, the ways they form and what they can do is quite amazing. You can learn a lot from stars, and you can learn how old things are. Stars help tell time in the universe. When it comes to stars, many of them fail, many of them explode, and there's so many different types of them. But first off, what even are stars? Well, one of the easiest analogies for stars is written by Charles Choi. He stated they're kind of like onions. They have multiple different layers, from super hot outer layers to their cooler inner layers where fusion happens. According to NASA, however, they get a little bit more scientific based. For NASA's description, they are basically just gas held together by gravity. This gravity helps make the star form by pushing in on all the different molecules in it. At the same time, the star pushes outward. This makes the star keep its shape. The purpose of a star is kind of debatable. Some people say there's not very many purposes to them, and for our star, it has a couple more purposes than others do, because Earth is one of the only known planets that have actual life on them apart from bacteria. According to Dr. Wendy Su, which is the only person that I found who actually did any information on this, the uses of stars primarily are just heat and light. The heat keeps everything warm. It allows planets to heat up. It allows us to keep our different homeostasis between plants and animals. Light helps a lot of plants make food, and in turn, those plants feed other animals. It's a big cycle when it comes to Earth and their stars. Well, how do we get what we need? How do stars get what they need to do those functions? They form about the same. No matter what star you get, they all form relatively similarly. According to Schneider, they begin in interstellar gas. Interstellar gas is just gas floating around in space. Primarily, it is carbon monoxide and hydrogen and dihydrogen. In these clouds, it is extremely cold. This extreme cold allows the molecules to clump together. Once these molecules get to really, really heavy, they start collapsing in on themselves. This collapse heats them up to thousands and thousands of degrees. After a while, that heating, they turn to protostars. Protostars aren't often seen as their light is invisible to the human eye and to most radio waves. Most telescopes use those rays to see things. So sometimes you gotta make little alterations and use a different method. The gas in that center, like I said, heats up. Eventually, it implodes on itself enough and it gets dense enough to become a star. As time goes on, these stars eventually become the main sequence stars, which is the 90% of all stars in our galaxies, in our universe and galaxy, our sun included. As time goes on, however, these stars can turn into something else. Starting with the main sequence stars, these stars use hydrogen and helium to produce their heat and light. They can range from 40 million years to several trillion years old. They come in blue, yellow, red, and orange. According to Peter Christoph, you also have supergiants, and you have superstars. In these stars, there is no hydrogen left to burn, so they just burn helium. When it comes to these, you have blue giants, red giants, blue supergiants, and red supergiants. To get a blue star, there's times of slow fusion where the helium doesn't want to make energy in the stars. This causes it to expand, get hotter. At this time, it turns blue. Hotter flames are blue, the cooler ones are warm colors, I guess. While these stars are big and bold, you also have stars that fail. The most common stars that fail are called brown dwarfs. These stars bridge the area between planets and stars. There's a very small gap here. The only reason that brown dwarfs are considered stars rather than planets is because they were formed in interstellar gas and have the mass of a star. these stars did not have enough to ignite, but still had enough to be considered a star. When stars die, sometimes there's crazy things that happen. Most common things that happen are supernovas. Supernovas are basically implosions of the stars. These stars get super, super hot, super, super big, and explode. When these happens, you can get something called a white dwarf. White dwarfs are the smaller stars that did this process. They blow off all their layers and get to the size of about 1.4 solar masses, or 1.4 times our sun's size. You can get a neutron star, which is very similar to this one. However, rather than blowing off the layers, this star collapsed in on itself and tightly packed itself together. These stars are very, very small. However, they live for almost forever. Next, you got the black dwarfs. Black dwarfs are hypothetical. There's no proof of them yet. To get a black dwarf, a white dwarf star has to die. However, white dwarf stars live for trillions and trillions of years. And if you know the age of the universe, it's not that old yet. Then you can get black dwarfs. Not black dwarfs, black holes. Black holes, pretty common. You see them in the middle of galaxies, and you can see them sprayed around the universe. These are supernovas of giant stars. They implode on themselves, and if they keep going too long, you get a black hole. Well, there's not that many purposes to stars. They're useful for us more than any other place in the universe that we know of so far. We're the only place that really uses the heat and energy of the sun. Imagine, what would our life be like if we had a different star? What would it be like if we had a dead star or a supergiant star? Our star eventually will become one of these supergiants as time goes on, as stars tend to expand as they get older. You think life would change? Or would it be the same as it is now? Who knows? Maybe a long time from now.